Hello and welcome to Maths, where we teach Maths for students and by students. Today we'll be talking about Binomial Theorem. So what is Binomial Theorem? Well, Binomial Theorem is a formula for finding the expansion of a binomial to any power. For example, x plus 5 to the power of 5. So before we go into this, I just want to talk about a basic that you'll need to know for this idea, and this is called factorial. So what is factorial? Well, factorial is this exclamation sign, and then this sign here basically means, it's really simple, but you'll see it a lot in maths. It's new, I don't think you study this in GCSE, but it's actually really simple and it's also really important. So let's say you have 5 exclamation mark, 5 factorial. So what is this? This is 5 times 4 times 3 times 2 times 1. So what is this? That's 5 times 4, 20, times 3, 60, times 2, 120, times 1, 120. So 5 factorial is therefore 120. Another example of this, something similar, 2 factorial. This is just 2 times the previous number, 1. So it is 2. Then let's say 9 factorial. This is going to be 9 times 8 times 7 times ... You get the idea. It's just n factorial equals n times n minus 1 times n minus 2 all the way to 0, more or less. You don't count 0, but it's all the way to 0. Now let's talk about another basic we have. Imagine this isn't 5 now. Imagine we take a 2, where it's just x plus 5 times to the power of 2, squared. This is really basic. We do this in GCSE. This is just x plus 5 and then x plus 5. We do x times x, x squared, x times 5, 5x, and then 5 times x, 5x, plus 5 times 5, which is 25. This is just x squared plus 10x plus 25. I would only ever use this expansion method if it's to the power of 2 squared, possibly even 3. I wouldn't really go much further than this, as this would be very time consuming. Now I'm going to show you an example for when it's above a cubed probably, and it's called Pascal's triangle, this up here. Let's say you have once again x plus 5 to the power of 5. So this is Pascal's triangle, and in algebra we use this to give the coefficients of a binomial expansion. So as you can see, it's a sequence, 1, 1 on each side, and 2, 3, 4, and it's just this, which is called Pascal's triangle. And this is actually really important. You can memorize it. I'm not sure if you have it in your data booklet, but it's really important. So the first thing you want to do is, when you're giving your binomial, look at the coefficient, look at the what power it is, and in this it's 5. It's to the power of 5. So you want to come here and go 0, 1, 2, 3, 4, and 5. Right there. So it's 1. Let me open a new one. It's 1, 5, 10, 10, 5, and 1. Let me just quickly open a new one. So once again, 5, 1, 5, 10, 10, 5, and 1. And since it was x to the 5, the first thing we want to do, it's in descending powers of x, so it's x to the power of 5, 5 to the power of 0, x to the power of 4, 5 to the power of 1, x to the power of 3, 5 to the power of 2, x to the power of 2, 5 to the power of 3, x to the 1, 5 to the 4, x to the 0, 5 to the 5. And then if we use, for this we can obviously use our calculator, we're not expected to know 5 to the power of 5. And this, if we do x to the power of 5 times 1 times 1, it's just x to the power of 5. Then 5 to the power of 1 is 5, times 5, 25, 25 x to the 4th, plus 250, because we have 10, times 5 to the 3rd, which is 250, x cubed, plus, now we have 5 to the power of 4 times 5, x squared, sorry, right here, and this is 1250. I am using my calculator for this. I don't think you'd be expected to know this. Now we go here, x to the 1. As you can see in each one, the x is going from 5, 4, 3, 2, 1. It's descending powers of x. It's really important you know this because in your exam question you'll be expected to know if it's descending or ascending powers of x. If it was ascending powers of x, you'd do the opposite, starting from 5 to the power of 5, x to the power of 0, and build your way down. So this would be 13125 x, and then the final one would just also be 3125 with no x. So this is the expansion of x to the power of x plus 5 to the power of 5 using Pascal's triangle. As you can see, we use the triangle in the previous page. We went to the 6th row because we don't count the number 1 at the top, and we used the coefficients and multiplied it by 5 to the power of whatever it was in the situation. So therefore, I would recommend if it's above to the power of 3, if it's to the power of 4 or more, I would surely recommend Pascal's triangle, probably all the way up to the power of 6, not further than to the power of 6. This is of course personal, and this is just the preference I have. Now let's go into binomial theorem. So let's use the same example again, because now you already know the answer and you've done it through Pascal's triangle. I'm going to use this exact example, but I'll show you now what the main difference would be. It's still to the power of 5, but I would surely recommend binomial theorem if this was, for example, to the power of 7, 6, anything 6 plus, more or less. So the first thing you want to do is in this bracket, imagine the x is an a, and the 5 is a b to the power of 5. So the first thing you want to do is look at this 5 up here. This is when the factorial that I showed you before is going to come into play and where it's going to be most significant. So the first thing you want to draw is to draw this big C. It's how it's presented in the data booklet, and it's how I recommend you present it. And you want to put a 5 on the top and a 0 on the bottom, because that's the first one. It's 5 and 0. Then A, you want to come to the A. And you're going to go A to the power of 5, B to the power of 0. Then in the next one, C to the power of 5, 8, and then no 0, 1. It's 0, then 1. But now the main difference is you subtract 1 from the A, same as we did with the Pascal's triangle. A to the 4th, B to the 1. As you can see, this is a sequence. We're adding 1 each time. Taking 1 away from A minus 1 each time, B plus 1. And we're adding 1 from here. So the next one would be C5 to A3, B squared. Then C5, 2B3 plus C5, 4A. It's going to be 1B to the power of 4, and then the final one, C5, 5 now, so it's both this, and then A0, so the A will no longer be present in this final one, same as the B wasn't present in the first one, now the A won't be, and B to the power of 5. Just remember this, it's really important, it's confusing, the equation you're given is usually really confusing, but just remember this. So now we want to look at this. What does this c mean? The 5. Well, this is when factorial comes into play, and this basically just means there's a fraction. On the top there's the 5, and on the bottom there's the 0 times 5 minus 0. But it's not just this, it's every number factorial. That's really important you remember this. It's just, now let's look at this one for example, 5, 1. That's 5 factorial, and then at the bottom 1 factorial, which is just 1. Well, this is actually quite a debatable one, but that's for a different video. Then 5 factorial, because it's the 1 at the top, which will always be 5. 5 remains a constant on the top for all of them, minus the 1, which is 4 factorial. And then for these you can obviously use your calculator, you're not supposed to know all these. But then this one here, since it's the first one, this adds up to 1. This is 1. So I don't know if you get the idea, but it's just basically whatever this is, imagine this is no longer 5, it's an n, it's n factorial, and then not n factorial, whatever number you're doing, imagine you're on the first term 0, 0 factorial, brackets n factorial minus 0 factorial. I'm using the 0, these are all going to be 1. Just remember, the first one is always going to be 1. Always. Okay, let's use this, the x to the 5, let's work through the example. Don't save, okay. Let's use it again. Just to make it easier, I'm not going to go all the way to the power of 5, I'm just going to do to the power of 4. So it doesn't take as much time, but it's the same idea for all of them. First thing we want to do, 4 on top, 0. Now the c, this is just a fraction, remember? Then x, which is the a, x is the a, and this is the b. X to the power of 4, 5 to the power of 0. Next is x, now we do c, 4, and now 1. Always the 1. 0, 1. Then x to the 3, 5 to the 1, plus c, 4, 1, x squared, 5 squared, plus, oh sorry, this is 2, sorry, just remember 0, 1, 2, this will be 3, that's 4, 3, c, x to the 1, 5 to the third. Now finally 4, c, x to the 0, no x in this one, which will be 1, and 5 to the fourth. Okay, so you get the idea. If you want, you can try this example. I would recommend, probably. I would even try a few more. I'm going to record a video after this trying different examples of binomial. But this is just an example of how it would work in a real life situation. I'm just going to try to summarize it now. What I would use for expanding binomials. Simple, like this, when you just expand. I would only ever use this if it's x plus b to the power of 2, possibly 3, no more than 3. Surely no more than 3. I would use Pascal's triangle when it is x plus b, probably from 4 to 6. No higher than 6, because it will just be a mess, you'll have to memorize a lot. But if it's, and then I would use this method. Binomial expansion, I would only ever use this method when it's x plus b probably 6 plus. This is just my personal choice. This is of course all up to you, but I hope this has helped you. I'm going to record another video now, show different examples. Hope you've enjoyed. Please comment if you still have any doubts, or if you think we could teach this better. If you want to record a video trying to explain it yourself, you're more than welcome to, and send it to us, and we'll look at it, post it, up to you. You tell us, but thank you for watching, and see you.